This is Pure 2, Chapter 4.4, which is about points of intersection. So you should have learned about three different sketching, actually four different types of graph, including Chapter 2. First type is quadratic graph, cubic graph, quartic graph, and reciprocal graphs. Okay, moving on, 4.4 about points of intersection, where we look at, graphical solutions, or actually not graphical solutions, just solutions of 2.2 graphs meeting each other. Okay, so the points of intersection of two curves, y equals f of x means a function of x, and y equals g of x, another function of x, means two different graphs, can be found by solving f of x equals g of x. So this is the key point in here. Oops, key point. Okay, key points of intersection. So when points of intersection or two lines meet, you have to perform simultaneous equation. So remember that when you see two lines meet, they intersect, okay, or even though you prove them do not meet, when you see two lines, two curves meet, simultaneous equation. All right. In chapter 3, you should have learned, should have been record how to solve graphical and not graphical, quadratic and linear simultaneous equation. Linear ones, you can use a calculator to solve it, remember. Okay, you don't get any extra marks for showing how to solve it because they will assume you can use a calculator. Quadratic wise, you'll get marks for showing how to solve it. Right, graphically, the number of intersection points equal to the number of real solutions to the equation f of x equals g of x. So the number of intersection points when you see on the graph. So for example, in here, just to make a quick example, if you have like this, okay, two lines, two straight lines, you can tell there's only one solution, right? Because they only meet once. But let's say if we have, let's say, a running graph like this, and a graph, and then another graph looks like this. Oops, I don't know, just a weird one. Okay. Then how many solutions are there when these two lines meet? Well, there are 1, 2, 3, 4, 5. Now, this is a bit extreme, okay? But I just want to show you basically any points that you see graphically to intersect means how many real solutions are there. Right. Example, find the coordinates of points of intersection of y equals da, 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 and y equals x squared times 1 minus x. Points of intersection. I see this word in my brain. It filters into simultaneous equation. Okay. It's a reflex. When you see a plate of chips, what do? You eat them. When you see the word points of intersection, what do you think of? Simultaneous equation. Same. Right, so then what do we do? Well, both equation equals to y equal, so we can now make them equal. So x times x minus 3 equal x squared times 1 minus x. This is the method of substitution. We substitute y into the other one. To solve this, now we cannot divide by x on both sides. I think I've mentioned this in quadratic. You can't divide both sides by x because once you divide it, you might lose that one solution. The way we should do it is we expand the brackets on both sides. Okay, there are different ways you can do it. Okay, so one way is to expand the bracket x squared minus 3x equal x squared minus x cubed. Then to solve the equation, we bring everything on one side and make one side equal 0. The x cubed, which is the biggest power, we like to make it positive. So we bring the negative x cubed to the left hand side to make it positive. So positive x cubed plus minus x squared minus x squared, they cancel out. Oops. They basically cancel out. So then we have, oops, okay, so x squared cancel out, minus 3x equals 0. What's next? We can't divide by x, we can factorize the x out. So x squared minus 3 equals 0. So then we have x equals 0 or x squared minus 3 equals 0. Then x equals 3, x squared equals 3, square root, x equals plus and minus root 3. So how many solutions are there? 3. X equals 0, x equals positive root 3, x equals negative root 3. Next, we need to find the coordinates. Coordinates mean that when there is x, there is y. So we also need to find a y solution. To find a y solution, we substitute into either one equation. This one looks simpler. So y equals, so I'm going to sub into y equal x times x minus 3. So when x equals 0, y equals to 0 times 0 minus 3, which is just 0. So the point is 0, 0. When x equals positive root 3, y equals to root 3 times root 3 minus 3. Now, how do we expand this? Oh, it looks a bit clumsy. a bit messy. What do we do? Put in a calculator. Just put in a calculator. So that calculator do work for you. Put the whole thing in a calculator. The calculator simplify for you. 3 minus 3 root 3. Next one, when x equals negative root 3, then y equals negative root 3 times negative root 3 minus 3. Again, put in the calculator. The calculator do the heavy lifting for you. You get 3 plus 3 root 3. So the points of intersections are root 3, 3 minus 3 root 3, and here negative root 3, 3 plus 3 root 3. Okay, and these are the answers. Right, now, before we move on, is there a different way you can do it? Is there a clever way, or if you feel like, is there like a, a smarter way, or, on show off, extravagant way? How do I show off? Okay, to show off your algebra skills, to flex your algebra muscles. There are ways you can do it. So I can show you. What about if we bring this left hand side? Okay, so x times x minus 3 minus x squared times 1 minus x equals 0. Now, how many terms are there? 2, 1, 2. Each term, they both have an x, so we can factorize an x out. Okay, so we can factorize x out. X times something give us x times x minus 3. It will be x minus 3. This one is x times 1 minus x. Because if we try to expand the bracket, x times that one is x times x minus 3. X times 1 minus x is x squared 1 minus x equals 0. Now, I would suggest students to do the ordinary way, left hand side. But if you really want to flex your algebra muscles, you can try this. Okay, just to train up your algebra skills. In here, expand the bracket, x minus 3 minus x plus x squared equals 0. Then you realize x minus x is cancel out. So you're left with x times minus 3 plus x squared equals 0. Now you can see 2 bracket equals 0, so x equals 0, or minus 3 plus x squared equals 0. Bring the 3 over, x equals 3. You can see it's the same steps as the left-hand side. Okay, just a different way to show off. Maths is fun. Right. But anyway, the answers are these ones. Okay, so have a go. Practice question 1. The only practice question, lucky you, in this lesson. So pause the video, have a go at the question. When you're ready for the answer, where I'll just give you a final answer, and I'll show you the workout later. Then you can press play. Here's the final answer for part A and part C. I didn't show you part B because either you can rearrange it or you can't. So if you can rearrange it, you don't need the final answer. I'll show you the steps in between, of course. Part C, one solution. Okay, if you got it right, well done. Okay, but if you don't understand why you got it right, or you want to listen to how I do it, continue. But if you don't, you can finish the lesson here. Question A, sketch two curves with same axes. So y equals 4 over x squared we learned it from last lesson about reciprocal graphs. So y equals k over x squared. Do I have the notes in here? Yep, y equals k over x squared looks like this. All right, this chapter 4.3, by the way. Okay, so k over x squared looks like this. So yeah, so like a mustache. Yep. Next, and y equals x squared times x minus 3. Now that one you have to actually show the steps. So question A, to sketch graph y equals x squared times x minus 3. We know this is a cubic graph. So the shape cubic graph is a positive x cube. Positive x cube meaning we start from the bottom. And then we have x equals 0. When x equals 0, y equals 0 times 0 minus 3, which is just 0. And then when y equals 0, then you have 0 equals x squared times x minus 3. So x squared equals 0, or x equals 3, x equals 0. There's a double root. Double root means touch and turn. So when x equals 0, equals 0, touch and turn, x equals 3. That's the answer for part A, right? Part B, show that the equation could be rearranged. So let's try that. So 4 over x squared equals x squared times x minus 3. The question wants us to convert this into the answer like this. So we want to make one side equal 0. But before we do that, there's no fraction. So what do? To get rid of the denominator, we multiply every term by x squared. So we multiply left and right by x squared. So left hand side, we multiply 4 over x squared by x squared. They cancel out. Right hand side, x squared times x squared, x to the power 4 times x minus 3. What about the bracket? Do you not have to multiply this by x squared? No. This is a common mistake. No. Reason being is this is one term. So think of this, okay? Think of this, okay, as 4 times 2 minus 1, for example, 4 times 2 minus 1. If I multiply this whole thing by 3, right, what I'm doing is I'm just doing 4 times 2 minus 1 times 3. And do I have to multiply this by 3 as well? No, because they are one term. If it's a 4 plus 1, I need to times it by 3. Okay, let's say, then I'll need to do 4 times 3 and 1 times 3. So anyway, that's a bit of difference. Ultimately, when they're connected by a bracket multiplied together, that means they're one term. These are some silly small things that students usually overlooked at when they do algebra. So then when you expand the bracket in here, then you can have x to the power 5 minus, oh, actually, x to the power 5. I'm actually second guessing myself in here. I know something is off because the question does not have x to the power 5. So that's a bad move. I should not expand the bracket. What should I do? Well, they make one side equal 0. So why don't I follow suit? Bring the 4 over, subtract it. And here we go. And that's my answer. Same as the question. Okay. Part B, using a sketch, state with a reason the number of real solutions to the equation x to the power 4 bracket x minus 3 minus 4 equals 0. Now, if we look at this equation here, where does this come from? Now, look at part B. This is the same as this one, where one graph on the left side, the other graph on the right side. So that's the same as f of x equals g of x. So how many solutions to this equation? Well, we'll look at how many intersection point of the graph. One. Yeah. That's one intersection point. So part C is 1 because there is only one intersection point on the graph. Simple as. All right? And that's the end of lesson.